Hi everyone, this is Tutor Marife MCP. I create math video lessons that could serve as your supplemental learning resources. In this video, you will learn how to write the standard form of the equation of an ellipse when the given information is the coordinates of the foci and the coordinates of the vertices. Let's read the problem. Find the equation of the ellipse that satisfies the given conditions. The foci are at -1, 3, and 5, 3. The vertices are at -4, 3, and 8, 3. Let's review the two standard forms of the equation of an ellipse. The first form is quantity x minus h squared over a squared plus quantity y minus k squared over b squared equals 1. The other form is quantity x minus h squared over b squared plus quantity y minus k squared over a squared equals 1. H and k represent the x and y coordinates respectively of the center of an ellipse. A represents 1/2 of the length of the major axis, or the distance between the center and the vertex of an ellipse. B represents 1/2 of the length of the minor axis, or the distance between the center and the co-vertex of an ellipse. Remember that the major axis is the longest diameter of an ellipse, while the minor axis is the shortest diameter of an ellipse. Therefore, if A represents 1/2 of the length of the major axis and B represents 1/2 of the length of the minor axis, then A is always greater than B. It follows that A squared is always greater than B squared. When writing the standard form of the equation of an ellipse, it is important that you know how to choose the correct standard form for the given problem. Let's observe the difference between the two standard forms of the equation of an ellipse. Look at the denominators. The difference is in the positions of a squared and b squared. A is always greater than b. Therefore, a squared represents the larger denominator. The larger denominator, or a squared, is always placed under the variable related to the major axis of an ellipse. Just think of your x and y axis. The x-axis is the horizontal axis. So we always relate x to the horizontal major axis of an ellipse. If the major axis of an ellipse is horizontal, we place the larger denominator, or a squared, under x. The y-axis is the vertical axis. So we always relate y to the vertical major axis of an ellipse. If the major axis of an ellipse is vertical, we place the larger denominator, or a squared, under y. So how do we know whether the major axis of an ellipse is horizontal or vertical? When the given information is the coordinates of the foci and the vertices. One way is by plotting the foci and the vertices. The line segment joining the foci and the vertices is the major axis of the ellipse. If the line segment joining the 4 points is horizontal, then the major axis of the ellipse is horizontal. If the line segment joining the 4 points is vertical, then the major axis of the ellipse is vertical. Another way is by inspection. If the y coordinates of the foci and the vertices are the same, then the major axis of the ellipse is horizontal. If the x coordinates of the foci and the vertices are the same, then the major axis of the ellipse is vertical. Let's refer back to the given coordinates of the foci and the vertices. The y coordinates are the same. Each point has a y coordinate equal to 3. Therefore, our major axis is horizontal. If our major axis is horizontal, we are going to use the standard form with the larger denominator, or a squared, placed under variable x. After choosing the correct standard form of the equation of the ellipse based on the major axis, the next step is to identify the coordinates of the center of the ellipse represented by h and k. H represents the x-coordinate of the center. K represents the y-coordinate of the center. We can find h and k in three ways. First way is by inspecting the graph of the major axis, or the line segment joining the given vertices and foci. The center, or the midpoint of the line segment, is obviously at this point. H, or x, is equal to 2. K, or y, is equal to 3. Another way is by solving for the coordinates of the midpoint of the line segment with endpoints at f sub 1 and f sub 2. So how do we solve for the coordinates of the midpoint when we know the coordinates of the endpoints? We add up the x-coordinates, then divide by 2 to solve for the x-coordinate of the midpoint. We add up the y-coordinates of the endpoints, then divide by 2 to solve for the y-coordinate of the midpoint. So h is equal to -1 plus 5 divided by 2. -1 plus 5 is equal to 4 divided by 2. 4 divided by 2 is equal to 2. K is equal to 3 plus 3 divided by 2. 3 plus 3 is equal to 6 divided by 2 equals 3. So HK is equal to 2, 3. The third way is to find the midpoint of the line segment with endpoints at V sub 1 and V sub 2, or the vertices of the ellipse. V sub 1 is at -4, 3. V sub 2 is at 8, 3. To find H, add up the x-coordinates, then divided by 2. -4 plus 8 divided by 2. -4 plus 8 is equal to 4. Divided by 2 equals 2. K is equal to the sum of the y-coordinates, then divided by 2. 3 plus 3 divided by 2. 3 plus 3 is equal to 6 divided by 2 equals 3. HK is equal to 2, 3. So we can find H and K in three ways. After identifying the center of the ellipse, or the H and K, the next step is to find the value of a squared, or the larger denominator in the standard form of the equation of the ellipse. Remember that a is equal to 1/2 of the length of the major axis, or is the distance between the center and the vertex of the ellipse. We can find a in different ways. One way is by inspecting the graph of the major axis. By inspecting the graph of the major axis, we can see that the length of the major axis is equal to 4 units plus 8 units equals 12 units. 1/2 of 12 units is equal to 6 units. Therefore, a is equal to 6 and a squared is equal to 6 squared, or 36. Another way of finding a is by considering that a is the distance between the center and the vertex of the ellipse. Let's consider the first vertex and the center of the ellipse. By inspecting the graph of the major axis, the distance between the first vertex and the center of the ellipse is equal to 4 units plus 2 units equals 6 units. Again, a is equal to 6 and a squared is equal to 6 squared or 36. Another way of finding a is by solving. By solving, we take the absolute value of the difference between the x-coordinates of the center and the vertex of the ellipse. You can use either of the first vertex and the center or the second vertex and the center. Either of the two pairs would give you the same answer for A. Let's use the first vertex and the center. The x-coordinate of the first vertex is -4. The x-coordinate of the center is 2. The difference between the x-coordinates is -4 minus 2, or 2 minus -4, which is equal to -6 and 6 respectively. Taking the absolute value of those differences means disregarding the sign. So absolute value of -6 is equal to 6. Absolute value of 6 is also equal to 6. Therefore, a is equal to 6 and a squared is equal to 6 squared or 36. After finding a squared, the next step is finding c squared. What does c represent? C is the distance between the focus and the center of the ellipse. By inspection, we can see that the distance between the first focus and the center is 1 unit plus 2 units equals 3 units. Therefore, c is equal to 3 and c squared is equal to 3 squared or 9. Another way of finding c is by solving. By solving, we take the absolute value of the difference between the x-coordinates of the focus and the center. Let's use the first focus and the center. The x-coordinate of the first focus is -1, while the x-coordinate of the center is 2. The absolute value of the difference between -1 and 2 is absolute value of -3. Disregard the sign, the absolute value of -3 is equal to 3. So c is equal to 3 and c squared equals 3 squared or 9. Another way of taking the difference between the x-coordinates of the first focus and the center is going towards left. So the absolute value of 2 minus -1 is equal to absolute value of 2 plus 1 or 3. Absolute value of 3 is equal to 3. So c equals 3, c squared equals 3 squared or 9. After finding c squared, the next step is finding b squared, or the smaller denominator in the standard form of the equation of the ellipse. To solve for b squared, we are going to use the equation c squared equals a squared minus b squared. Replace c squared with 9, replace a squared with 36. This equation becomes 9 equals 36 minus b squared. To solve for b squared, we need to isolate it on one side of the equation. Let's transpose it to the left side to make it positive. Let's also transpose 9 to the right to collect the constant terms on the right side of the equation. This equation becomes b squared equals 36 minus 9. Simplifying the right side of the equation, the value of b squared is equal to 36 minus 9 or 27. After completing the information that we need to be able to write the standard form of the equation of the ellipse, we are now ready to do the final step of the problem. H is equal to 2, k is equal to 3, a squared equals 36, b squared equals 27. This is the correct standard form of the equation of the ellipse. Our final answer is x minus 2 squared over 36 plus y minus 3 squared over 27 equals 1. This is our answer. That's it. If you have any questions, you want further clarification, or you want to give a feedback on this video, feel free to post your comments. Again, this is Tutor Marife MCP. I thank you for taking the time to watch my video.